Hello, everyone. Let's go ahead and get started on a lecture on effective interest rate. So this lecture, we're gonna use a lot of the concepts from compound interest. We've seen that before. We've done some problems on that, and so we're gonna actually talk about how to compare different types of compounding interest. And when I say different types, really all I mean is just how often do we compound. So let's go ahead. This is going to be a pretty example heavy lecture. I'll kind of explain what effective interest rate is through examples. So let's go ahead and get started. Um, so starting right off here, let's suppose that I invest $5,000 in a bank account and I have a 4% interest. And we'll say that's a yearly interest. So over the course of a year, what I want to know is how much money do I make if the interest is compounded quarterly, and compare that to how much money I would make if the interest is compounded annually. And really what I want to know is which scenario would I make more money, which scenario would I make less, and how much more would I make in these scenarios. And so we can actually just go ahead and do two different compound interest calculations, one with it being compounded annually and one with it compounded quarterly. So let's go ahead and do that right here. Let's go ahead. So we'll use our formula. A equals P times 1 plus R over N to the NT. This is our formula for compound interest. Let's put that right there. And then what we're going to set up is, so I'll label A sub A, and that small a is just for annual. And we're starting with 5,000, so that's good. We have that. And then that's going to be multiplied by 1 plus my interest rate written as a decimal, so 0.04. And we're compounding annually, so N is going to be 1. And then N is 1 there, so I can plug that in. And then the time is 1 year, so I say that as well. And then likewise, what we can also set up, let's go ahead and separate things out a little bit. So we can set up this quarterly calculation as well, and I'll label it A sub Q, Q for quarterly. Again, we have 5,000 that we're starting with. That's our principal amount. 1 plus our interest rate, which has not changed, divided by 4. And then 4 times 1 is, not T, 1. And so that's that quarterly. So N would be 4. And now basically we can just calculate these. We can just see what we get. And I'll do this quickly. We don't need to worry about showing all the steps here just for this example. Ooh, that's right, my comma is a little better. 5,200, and then here it would be 5,203 and 2 cents. And so this is something that we should have expected. If we were to compound our interest more frequently, we would expect more money, because the bank is going to, 4 different times a year, they're going to add money, they're going to add interest into my account, which means I now have more money in my account. So when they go to add interest again, there's more interest that's being added because there's more money in my account. And that just sort of keeps compounding, well, for lack of a better word. It just keeps sort of stacking on itself, and we end up with a little bit more money. Obviously, it's not a huge difference. In this case, it's $3.02. But hey, money is money, so we'll take it. And so, if you were given a choice here, you would say, hey, I want this to be compounded quarterly instead of annually. And really, you'd actually probably want to say, hey, compound this as often as is allowed, right? If they offer, if the bank says, hey, we'll compound it daily for you, you should do that, because the more often it's compounded, the more money you're going to make. Even if it is just a small, slight amount of money, it's still worth it. It's more money. So here's what I want to ask. And this question here, I'll say it is, we make 5,200 here if I compound annually at 4%. We make 5,203 if I compound quarterly at 4%. So what I want to know is, if I compound annually, but I change this interest rate, what would that interest rate have to be in order for me to get this amount of money? So basically everything I just said there, it's just saying, if I start with $5,000 and I compound annually, what does my interest rate have to be in order to get to this amount of money instead of this amount of money? And you could guess, you could say, hey, well, it's got to be a little bit bigger than 4%, right? Because 4% annually only got me to 5,200. So maybe if I go just a little bit higher than 4%, that'll get me to this point right here. And so with that question, we can actually answer this. We can do this mathematically and we can figure this out. So let's go ahead and actually set up that work. Got all this right here. That's good. We just did that. So let's actually set this up here. And this is gonna take a little bit of space. So I'm gonna give myself a new slide. Let's go ahead and copy this over. Come on. Copying takes a little bit of time. There we go. So we're asking ourselves this question of, hey, if I compound annually, what interest rate do I need to get to this 5203.02? So let's go ahead and set this up. Let's start off by plugging in what we know. We have our formula. I'll put it up here, nice and big, so we can just keep referencing back to it. So let's plug into everything we know. Well, A is our final amount, right? And we actually know what our final amount is. It's 5203.02. P is how much we start with, and we know that that's 5,000. 1 plus. R is what we're trying to find. We don't know what R is, so we'll leave that as the variable. N is 1. We're compounding annually. That's stated in that problem statement right there. N is 1 again, and then T is 1. We're going over 1 year. And so let's go ahead and just simplify. Well, 1 plus R over 1, that's just 1 plus R. And then it's raised to the 1, so it's just 1 plus R. So now I have 5203.02. I can divide both sides by 5,000, and I just get 1 plus R over here. And when I do that, division, I'm going to get 1.040604. We could keep going on with decimals, but I'm not going to bother. Equals 1 plus R. So then R is going to be equal to 0.040604, just subtracting 1 from both sides. And if I write this as a percentage, we're going to get 4.0604%. And so what we're seeing here is that if I were to have an interest rate of 4.0604%, and I start with $5,000, that's going to get me to this 5203.02. And so here's what you could say. You could say, well, if I compound at 4% quarterly, that's going to get me to this value. If I compound at 4.0604% annually, that's also going to get me to this amount. And that's a big thing right there. So what we could say, just nice and succinctly, we could say that compounding quarterly at 4% is the same as compounding annually at this slightly higher percentage right there. We end up with the same amount of money after that 1 year. If you compound quarterly at 4% and you compound annually at 4.0604. Just to rewrite these, we already did both of these calculations, but if we have 5,000 times 1 plus 0.04 over 4 to the 4 times 1. We did this calculation already. And then if we do this calculation, 0.0604, I'm trying to test my memory there, over 1. Let's give myself a little bit more space. Got to raise this to the 1 times 1. These two, the A1 calculation and the A2 calculation, those are the same exact thing. And we've done both of these calculations. And if again, this is confusing, plug both of these into your calculator and you'll see that in fact you do get the same exact number. You get $5,203.02. So compounding quarterly at 4% is the same as compounding annually at 4.0604%. So what we say is that this 4.0604%, that is an effective interest rate relative to this compounding quarterly at 4%. So if someone says, hey, you want to compound quarterly at 4%, hey, by the way, that's an effective interest rate of 4.0604. They're just telling you what the interest rate is if it were to be compounded annually. And it's a little bit easier to do your math on. And so it's basically just a different way of describing your interest rate. And really what it does here is it gets rid of the need to say that your interest is compounded quarterly or weekly or monthly or whatever it may be. It just said, if you just say effective interest rates all the time, then you're always talking about annual interest rates. And a lot of time that's actually what people who lend money, when you get a loan from a bank or from a credit card or a mortgage on a house or things like that, they generally just state the effective interest rate, because it's just a lot easier for people to be like, okay, cool, it's 4.06% a year, great. And they don't have to worry about saying, hey, it's 4%, but it's compounded quarterly. They can just say, hey, it's 4.06% a year, and it's the same exact math, it's the same exact thing. The amounts that you would get are the same. So all of this work that we've done was quite a bit of work. I mean, we started off with this. We started off by comparing these two amounts right here. We did these two different calculations, and then we sort of backtracked and we figured out, hey, how can I start with 5,000 and get to 5203.02? What interest rate would that be? And then we go back and we check our answer to make sure. That's a lot of work. And so really what we can do is we can boil all of that work down into this nice succinct formula. This is a formula I recommend just memorizing. There's not really much more to it. You could obviously go through all of the steps that we just did, but there's not really a point of doing that because we have a formula that calculates it all right here for us. One thing that I will really note in this, I really want to bring attention to this in this formula. There is no time, there's no T in this formula. And that should be something that makes sense. Time does not affect this effective interest rate calculation. It doesn't have any bearing on what the effective interest rate is. It doesn't matter if you're doing this for a year, for 10 years, for 40 years, or for 2 days. It doesn't matter. The effective interest rate doesn't change based on time. So let's go ahead and use this formula. Copy this over. We're going to use this formula. We're going to do an example just using this formula. We'll see how much easier it actually is. So find the effective interest rate of an investment with a rate of 6% that is compounded monthly. So you walk into a bank, they say, hey, thanks for giving us your money. We're going to give you a 6% interest rate, and that's compounded monthly. And you go, okay, well, if it's compounded monthly, could you tell me just what that ends up being after a year, right? How much interest am I going to get at the end of the year? What's my interest rate going to be? What's my effective interest rate if you were to just do this once a year instead of once a month? And they will do this calculation. They will take this formula right here, and they will plug everything into it, and they'll tell you what your effective interest rate actually is. And we'll go ahead and do that here. One other thing that I want to mention, sort of akin to how I said before that we don't have time in here. You'll notice we don't have our starting amount either. And in this question, I don't even tell us how much we start with because it doesn't matter. The effective interest rate doesn't depend on time, and it doesn't depend on that principal amount P, as you can see, because there's no T or P in this formula right there. So let's go ahead and do this. Let's plug everything in. So we've got 1 plus R, which is 6%. So 0.06 divided by 12, because we're compounding monthly, raised to the 12, minus 1. And then we can sort of go step by step here. 1 plus 0.005 to the 12 minus 1. Be careful on your order of operations here. We want to do everything inside the parentheses first. Then we want to raise that 12, do that 12 exponent. 1.06167778. I always like to keep a lot of decimals there. Subtract 1. We can convert this to a percentage. 6.16778%. And that would be our answer. And one thing I love about these problems, these effective interest rate problems, is that it's actually very easy to see if your answer makes sense, right? So if someone says, hey, we're going to compound our interest monthly, so every month we're going to see how much you have in your account, calculate the interest, add it in, and then now you have a new balance. Okay, a month goes by with that new balance, that higher balance, because they've added in interest. We're now going to calculate the interest again, add it in, boom. You're going to be getting more and more money. And so we would expect, if they, instead of doing it monthly, if they do it annually, because that's what effective interest rate tells us, the interest rate should be higher because we should be getting more money, right? If we want to make more money if we're doing it annually versus monthly in order for things to line up appropriately. And while it should be higher, it shouldn't be that much higher. I wouldn't expect an interest rate here of like 28%. That's just ludicrous. That's way more. And so with this interest rate here, that it's slightly higher than 6%. That's something that we would expect. And we can go ahead and just move on to whatever next example or problem you've got. One thing I want to mention here, what you can do to check your answer here, and also what you can do if this idea of effective interest rate is still confusing as to what it actually means. Here's what you can do. You can actually do two different calculations. So you can start off and you can pick any amount of money that you want to start off with. Like I said, it doesn't matter. Let's keep it simple. Let's say you start off with $1,000. And we're going to do a calculation here at 6%. And we're going to compound it annually. Sorry, monthly. I said annually, but I meant monthly because it's 12. That's our compounding. And again, it doesn't even matter how much time you do it for. The time doesn't matter. Heck, let's just say 5 years. Let's just do 5. Boom. And then if you do a separate calculation where, again, you start with the same amount of money, $1,000, and instead you use this interest rate of 6.16778, and then we do that annually, we compound annually instead of monthly, again, still 5 years. If you do each of these calculations, they are going to be equal. These are equal. A1 equals A2. And I don't have a calculator right on me, so I won't bother doing them exactly. But basically what we've got here is we're saying, okay, 6% compounded monthly. And here we're saying 6.16778% compounded annually. And you're going to get the same amount here. And this is exactly what effective interest rate says. Is effective interest rate says that if you do 6% compounded monthly, that is equivalent. You will end up with the same amount of money as someone who went 6.16778% and compounded annually. So you have a slightly higher interest rate, but you're also compounding less frequently. And so those things balance out just perfectly, and you end up getting the same amount of money, both people, if you will, if you've got person one and person two doing each of these things. So that's what effective interest rate tells us. And using this formula here, it's just a much faster way of calculating that. Great. So let's go ahead and move on to one last example here. And so I'm gonna ask this: which is a better investment, 4.25% compounded monthly or 4.3% compounded semi-annually? At a very first glance of this, sort of naively looking at this, I might think, one person might say, oh, well, the interest rate is higher here. than it is up here. So I want to go with this 4.3% instead of the 4.25%. But then someone else might counter with that by saying, hey, well, but in this case, I'm compounding more often in the monthly versus semi-annually. So I want to go with how when I compound more often. But here's what I'd say. We actually want to compare these with the same compounding rate. We want to sort of convert these each to an annual compounding rate so that we can actually see which has a higher effective interest rate in an annual sense. So what we can do is we can just do our effective interest rate formula that we had back here. Let's copy that again. Copy. So we can use this formula and just do it twice. We can just calculate this formula in both scenarios and see what our effective interest rate is. And when we do that, I've actually got that work typed up right here already. So this 4.25% that we're seeing compounded monthly, I've got my 4.25 and compounded monthly, and that ends up with an effective interest rate of 4.33%. So what we're saying is that 4.25% monthly equals 4.33% annually. And then if we do it again for the 4.3% semi-annually, so we've got 4.3%, we've got semi-annually, that 2 right there, we get this 4.346, which is just saying that 4.3% semi-annually, twice a year, is equal to 4.346% annually. And so now I have a direct comparison between these two scenarios. I've got my 4.3% annually right there. Make sure we get that highlighted. And I've got my 4.346% annually. And so this is really easy to say which one is better. It's definitely the second one. It's definitely this. This is a higher annual interest rate than this is. And so this 4.3% semi-annually is going to be slightly higher than the 4.25% monthly. So this would be a better investment. And we've used effective interest rate to do that. So we're sort of comparing these different interest rates by converting them both to annual interest rates using this effective interest rate formula. And this happens a lot, right? Maybe if you're going around from bank to bank getting, taking a loan out or something like that, or you're trying to invest money in a bank account, you want to know what your interest rates are. And one bank might tell you, hey, it's 4.25% compounded monthly. And one bank might tell you that it's 4.3% compounded semi-annually. And you're like, which one is better? I don't know which one is better because you're giving me different compounding rates and they're different interest rates. So who knows? Well, you can use this formula to just calculate it and figure out which is better or worse. One last thing I'll mention, if you were investing your own money and they were giving you money, you would want to go at a higher interest rate because you'll be making more money. That's where we've talked about where if you're investing, high interest rates are good because that means you're getting money. But if you were taking a loan out, so I've used the word investment here, but you could just say a loan instead. If you were taking out a loan, you want the smaller interest rate because if it's a loan, you have to pay someone back more money and you'd rather your interest rate be really small so that you don't have to pay them back as much. So for this problem, I say investment. So we would go with this as our answer right here. I'll sort of highlight that. This would be our answer right there because we're talking about an investment. But if I just changed this question right here, if I just crossed out investment and wrote loan, then we would say that our answer is 4.33% annually because it's smaller. We'll go ahead and leave that there. That'll be the end of the lecture, and I'll see you next time.